Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you through how to solve and work every problem on the big monstrous quadratic test review, the hardest unit in the entire year. So if you can push through this unit, then I promise you we'll have clear skies on the other side. So as always, my disclaimer, do not watch this video and just copy down the answers. You must work the problems yourself and then and only then come to the website, check the answers online, or watch the video to see where you might have made any mistakes or have a misunderstanding. So as my tradition, I always like to show you guys just a couple of cool things on my iPad. This is a cool little GIF image that I saw, just kind of a neat little image there. That one's pretty cool. That's a neat image. I like that one. Oh, that's pretty. I like that image. That's another cool image. I like that one. That's a pretty little image. Oh, that's a neat one. Oh, I like that one. Oh, that's beautiful. My two favorite colors. I love those images. All right, so let's jump on into the test review. In the first four problems, we're going to be solving our quadratic using the GCF method. So remember, these are equations. I'm actually solving to figure out what is my variable. Let me blow this up just a little bit. Okay, with the GCF method, we're only using this method when we don't have a C term. So if we write down our standard ax squared plus bx plus c equals 0. That's our standard form, our basic quadratic equation. Notice I've got the squared term, I've got the middle term, but I don't have the c term. I don't have that number, okay? So when you don't have that number, you can use GCF, and I'm simply going to factor out the GCF, which in this case is n. To figure out what's left over, I'm going to divide each of my terms by n. N squared over n, of course, is just n. Negative 8n divided by n leaves me with negative 8. And that's going to be equal to 0. When I do the GCF method, guys, every single time one of my answers is going to be 0. One of these guys has to be 0. So if I set n equal to 0, I literally get 0 for one of my answers. And for the other answer, I simply flip the sign inside the binomial. Flippy flip. So my answer will be 0 and 8. Okay. And you're going to do the same thing for the next three problems. Factor out an x here. That's going to leave me with x plus 3. Equals 0. One of my answers is always 0. And then flippy flip, 0 and negative 3. Same thing down here. Pull out an x. That will leave me with x plus 4 equals 0. One of my answers is 0. And the other one is flip that sign, flippy flip, negative 4. Okay. And the last one here, same thing. Notice I don't have a c term. No c term. No c term. I can use GCF. So I'll factor out a k. That will leave me with k minus 6. So my two answers are 0 and flippy flip, 0 and 6. Okay. As always with these quadratic equations, guys, whenever you're solving an equation, whenever you get x equals something, n equals something, to check your answer, you can always plug your answer back into the original problem. So if you guys want to get out your trusty calculator, yes, we'll be using our calculator a good bit in this test review, then I'm simply going to take my two answers and plug them in for k. So if I substitute a 0, if I take this guy and stick him in for k right there and stick him in for k right there, I'm saying that 0 minus 6 times 0, that better equal 0. And it does. So that's always a great way to check your answer. I'm not going to do those on, I'm not going to check every single one of these guys just for sake of time. This is probably going to be a little bit longer video anyway, since this unit is long. There's a lot of material in here, but you guys should be checking these. If you have time after the test, go back and any remaining time that you have, check every single one of these that you can. Okay, square root method. Let's move on to the square root method. All right, square root method, I don't have the b term. Okay, I have the square term, I have a number, but I'm missing this bx term. Okay, so notice here I've got the squared term, but I don't have an n term anywhere. I just have numbers. So that lets me know that I'm going to use the square root method. So I need to do whatever it takes to get that guy by himself, and then I'll take the square root of both sides. So in this case, I need to get n by itself, n squared by itself, so I'm going to subtract 10 from both sides. They cancel. So I have n squared equals 35 minus 10, which is 25. We're doing the square root method, so I'm going to take the square root of both sides. And yes, boys and girls, it is so easy to write n equals 5. For so many years, you guys have known that the square root of 25 is 5. No longer in geometry, when you take the square root of a positive number, you will always generate a plus or minus. So do not avoid falling into that trap on the test And when you take the square root, it's going to be plus or minus. Okay. Over here, what do I need to do to get v squared by itself? You know, the square root method, you can really treat the variable like it's just a regular variable that you guys did in coordinate algebra. What if this were 8v minus 200? You guys have been doing this since middle school. What would you do to solve for v? Well, you just divide both sides by 8, and you get v equals whatever it equals, okay? In this case, v would be 25. I'm going to do the same process here, but I just have a v squared, but the process is the same. I'm going to divide both sides by 8. I get v squared equals 25. And now I'm going to take the square root of both sides, and once again, I'm going to get plus or minus 5. Okay. All right, let's continue down. Just down a little bit. All right, number 7. Again, I'm trying to get a squared by itself. If you just imagine that a is, if this were just a 9a plus 8 equals 89, what would you do to solve? I'd move the 8 to the other side and divide both sides by 9. It's going to be the same thing here. Subtract 8 from both sides. 9a squared is equal to 81. I still don't have a squared by itself, so I have to divide both sides by 9, and I get a squared is equal to 9. Now I'm ready to take the square root of both sides, and I will get a is equal to plus or minus 3. So whenever you do the square root method, completing the square, anytime you're taking the square root of both sides, you're going to generate a plus or minus unless what? You're taking the square root of 0, which is a 0, or you're taking the square root of a negative. If you take the square root of negative, it's going to be NRS, no real solution. Okay. I'm going to move my keyboard over here so I can. There we go. Give myself a little bit more space. Okay, so number 8, square root method. Again, what do I need to do to get x squared by himself? You always want to undo the addition and subtraction in any kind of multi-step or two-step algebraic equation. So I need to move this 10 to the other side. So let's add 10. They cancel. 4x squared is going to be equal to 64. Okay. To get x squared by itself, I'll divide by 4. X squared equals 16. X squared. Take the square root of both sides, and I get plus or minus 4. And you know, guys, on the multiple choice test, you know your answers are going to look like this: 4, negative 4, 4, comma, negative 4. You know that's going to be one of the answer choices. So you've got to avoid picking that just the positive form there. Okay, it's got to be the plus and the minus form. Let's check one of these. I'll check maybe one of each of these just to show you how this works real quick. Okay, so we think that the answer is plus or minus 4. All right, so I'll take the positive form first, and I'll plug it in for x. So I'm going to type in negative 10 plus 4 times, we're saying that x is equal to 4, so times 4 squared, and that better equal what? That better equal 54, and it does. Okay. So if you have time, you could check both versions, but in this case we know it's plus or minus 4, so if the positive works, and of course the negative is going to work as well. Number 9, students like to make this more complicated than it is. We want to solve these equations by factoring. Factoring when a is 1 or factoring when a is not 1. Well, guess what? When we factor, we're going to end up with some parentheses, some binomials, right? X plus 2 times x minus 9, that kind of stuff. We're already factored. We're already in this factor form, so all I need to do is flip the signs. Okay, so in this case, x equals negative 6 and positive 8. And that's it. That's all you have to do. You just flip the two signs, 6 and 8. All right, number 10, what are the factors of 40 that add to negative 13? This is an understood one here, so we're factoring when a equals 1. A equals 1. You don't have to do the rainbow thing. There's no splitting, there's no curtain, there's no grouping, there's none of that stuff when a equals 1. I just look, what are the factors of 40 that add to negative 13? What times what gives me 40, and what plus what gives me negative 13? Now, a lot of you guys can do this in your head very quickly. Some of you guys struggle a little bit with this. So if you're having trouble figuring out factors of a number, use a little calculator trick that I showed you. We're going to go to y equals and type in the number that we're trying to find factors of, the big number, in this case 40, and then you're going to press divided by x, the number divided by x, and then go second table, and then I'm simply looking down through my table of values to see a combination of numbers that will somehow get me to a 13. All of these numbers on the right and the left will multiply to give me 40. 1 and 40, 2 and 20, 4 and 10. 4 and 10 doesn't give me 13. Ah, there we go, 5 and 8. 5 and 8 will somehow get me to a 13. But notice, that the middle term is negative and the c term is positive. So that means both of the signs have to be the same. It's either 5 and 8 or it's -5 and -8. So if they have to add to a negative, that means both of these guys have to be a negative. -5 times -8 is 40, and -8 plus a -5 is -13. So once you get these two numbers, guys, just like over here, when we factor, we're going to have two sets of parentheses. Okay, so what goes in the two binomials? It's just these two numbers. And since we're using r's, it's -8, so it's r minus 8, and -5, so it's r minus 5. That's how it factors. That's not the answer. We got to set this equal to 0 and actually solve. But since we're factoring, and since there's that imaginary understood 1 right there, all we do is flippy flip. Flip that sign, flip that sign. So r equals 8 and 5. All right, I'll plug one of these back in for you just to check our answers. Okay, so let's plug it. Let's choose the 8. It won't matter. Let's stick in an 8 for r squared. So 8 squared minus 13 times r, which is 8, plus 40. That better equals 0. Ta-da, it does. We could do the 5. 5 squared minus 13 times 5 plus 40, that better equals 0. It does. Guys, that took me 10 seconds. 10 seconds to check my answer. So please don't turn in your test until you've gone back and checked every single one that you can, okay, if you have time. Don't get hung up on checking every single one as you go because you might run out of time, but at the end, go back and check. Okay, flip on over to the back, and we got some more factoring. We're still in the factoring category. All right, so factoring, this is a equals 1. Okay, there's an understood 1 right there. Okay, that's good news. This is the easy version. What are the factors of -56 that add to 1? And I find that students get confused when they don't see a number in the middle. Well, what am I trying to do here? Well, what is the understood number? The understood number is 1. So I got to find two numbers that multiply to give me -56 that will add to give me 1. That means if they add to give me 1, that means one of them, they're side by side, 4 and 5, 10 and 11. They're back to back. Okay, so what times what gives me -56, and at the same time, what plus what gives me a +1. So once again, some of you guys may struggle a little bit with that, so we can go back to our y equals, let's type in 56 divided by x, second table, and I'm looking for a combination of numbers that will get me to a 1. In other words, that are 1 apart from each other. No, those are way apart, way apart, way apart. Well, there we go, 7 and 8. They're only 1 apart, okay? So the question is, when this back term is negative, one has to be positive, one has to be negative, because that's the only way to multiply two numbers to get a negative. So it's either 7 and -8, or it's -8 and +7, or -7 and +8. Which one is it? Well, the sign of the middle number determines the sign of the bigger one. Since that's positive, it's going to be a +8 and a -7. That multiplies to give me -56, and 8 minus 7 gives me 1. Okay, so once again, there's no splitting, there's no curtain. When a is 1, just bam. Two binomials, stick those numbers in the binomials. We're using n, so it's n plus 8 and n minus 7. Okay, that's how it factors. And then we flippy flip. Flip the signs, -8, +7. Okay, I'll let you guys plug those back in to check. 12, a is 1, that's good news. Are there any factors of 32 that add to 12? What times what gives me 32, and at the same time, what plus what gives me 12? Okay, well, once again, we can use our factors if you can't do that in your head. Let's go y equals 32 divided by x, second table. And I'm looking for somehow, how can I somehow get to a 12? There we go, 4 and an 8. Okay, everything's positive, so that makes it easy. I know everything in the whole problem is positive. So that just factors as k plus 4, k plus 8 equals 0, and flippy flip. -8 and -4. Okay, let's continue. What do you notice about 13 and 14? Okay, a is not 1. Okay, we're factoring when a is not 1. A is not 1. Okay, so when a is not 1, this is when we have to try to do the rainbow thing. Multiply the first term, the first coefficient, times the a term times the c term. So I'm multiplying 7 times -2, that's a -14. What are the factors of -14 that add to the middle term 5? Well, once again, I always start with the first two numbers that pop in my head. When I think of 14, I think of 7 and 2. So is it 7 and -2, or is it -7 and +2? The middle sign is positive. So that's going to be a +7 and a -2. And now, since a is not 1, now we do have to split that middle term. I'm gonna match the 7 with the 7. That makes sense to me. So I just bring down the front term, the first term, 7b squared, and then I split this into a plus 7b and a minus 2b, and then I just bring down the minus 2. So look at what we've done. We've taken $5 and we've separated it into $7 minus $2. It's still $5, but now I've taken 3 terms and I've forced it to become 4 terms so that I can do the curtain. I can do the grouping. What is my GCF on the left? They both have a 7b in common, so I'll factor out a 7b. That will leave me with b plus 1. Remember, this front term is negative, guys. You got to pull out that negative with it. You can't just factor out a 2. So you got to factor out a negative 2. If I divide both of those terms by negative 2, that will also leave me with b plus 1. They match. That's good news. So one of my factors is the matching binomial, b plus 1. Other factor is the stuff left over on the outside, 7b minus 2. Right? We're still not done. That's just how it factors. Okay, so this binomial, that has a 1 in front. So when there's a coefficient of 1, all you have to do is just flip the sign. Flippy, flippy, flip. Now this guy, I can't just flippy flip. I have to come out here to the side, and I actually have to set 7b minus 2 equal to 0, and I got to solve that. So 7b minus 2 equals 0. I'm going to add 2 to both sides. I get 7b equals 2 divided by 7. And my other answer is 2/7. Okay. All right, here's another one where a doesn't equal 1, so I've got to do the rainbow thing. 4 times 9 is 36. Are there any factors of 36 that add to 15? Okay, let's try to do this in our head. First two numbers I think of at 36 are 6 and 6. No, that doesn't give me 15. Then I think of 9 and 4. 9 and 4, that's 13. That doesn't give me 15. Well, we went from 6 down to 4. What about 3? Does 3 go into 36? Yes, it does. 3 and 12. Okay, so those are my two factors. So I'm going to choose to match the 4 with the 12. So 4m squared plus 12m, I'll match the 3 with the 9, plus 3m plus 9. All I've done is I've taken 15 m's and split it into 12 m's and 3 m's. All right, now I'm ready to draw my curtain and group. I can factor out a 4m. 4m divided by 4m leaves me with m. 12m divided by 4m, the m's cancel, that leaves me 3. Just to refresh your memory on how to do that. Y'all should be really good at this by now. We've done this a bunch. What can I factor out here? I can factor out a 3. That's going to leave me with m plus 3. They match. So m plus 3 is one of my factors, and then the outside stuff is my other factor. 4m plus 3. I'm going to set these equal to 0. Can I flippy flip here? You betcha. Just flip the sign. Alright, so one of my answers is going to be negative 3. This guy, I have to come out here and actually set this little expression equal to 0 and solve this little mini two-step equation. Subtract 3 from both sides. 4m equals negative 3 divided by 4. And my second answer is negative 3/4. Okay, negative 3/4 for the second answer. Okay, so in the next couple of problems, we are going to be completing the square to solve. Now remember, we've been completing the square to go from standard to vertex form in the past week or so, and this is, you gotta knock off the dust and dig deep and get back in our time machine and go back to remember, how do we actually complete the square to solve? This is the method where we're going to have a plus blank on the left and a plus blank on the right, and we're not going to be offsetting anything in this method. So the first thing I got to do is isolate the constant. This is the only method, guys, that I don't want it set equal to 0. I need the constant on the right hand side of the equation. So I'm going to have a squared minus 2a, and here's where I have my first plus blank. Okay, that's where we're going to complete the square. And then on the right hand side, I just combine like terms. 4 and 5 is 9. And then I'm also going to have a plus blank over here. Okay, so whatever number goes in this blank, if I put 50 bricks over here, I got to put 50 bricks over here to keep my equation balanced. All right, so what number goes in that blank? How do you complete the square? It's half of b squared, half of b squared. Take half of the middle number and I square it. The middle number is negative 2. So when I divide negative 2 by 2, I get negative 1. And when I square negative 1, I get 1. So I will stick a plus 1 in that blank. I must also stick a plus 1 in that blank. Keep my seesaw, keep my equation balanced. Now, how does this perfect squared trinomial, how does it factor? Okay, I know it's going to be a parentheses squared piece. Every time I complete the square, when I get down to the end, I know I'm going to have a parentheses squared piece. Okay, so to figure out what goes in that is simply just half of the number, half of b. Okay, so if I take half of -2, that gives me -1. Okay, so an a minus 1 goes in the parentheses squared. Right. So a minus 1 squared is going to be equal to, now over here I just combine my like terms. 1 plus 9 is 10. And then the last step is to use the square root method. I'm going to take the square root of both sides. If I take the square root of something squared, I just get itself. So the square root of a minus 1 squared is just a minus 1. And when I take the square root of 10, guys, remember I always generate a plus or minus. So it's plus or minus the square root of 10. Okay, the last step, I just need to move this 1 to the other side. So my final answer, I'm not adding the 1 to the radical. I've already seen a few of those mistakes. The 1 just stays on the outside, so it's just 1 plus or minus the square root of 10. Now if you want to check this, you can't really type, it's kind of hard to type this into your calculator to plug it back in for a. So what I would recommend if you have time is go ahead on your calculator, just go ahead and get a decimal. So I would just do 1 plus the square root of 10, get a number. Okay, so then if you want to plug that back in, I would plug that back in here. So I would just do second answer, I would square that number, okay, minus 2 times second answer, the number we just got, minus 5, and that better equal 4, and it does. Okay, so that's a way to check your answer on those types of questions. But kind of what I've gathered from you guys in the past couple of days is most of you guys are kind of struggling to remember how to do this method to solve, and so a lot of you guys are probably going to lean towards the quadratic formula. And on the test, since it's multiple choice, you know, I don't have a way to know which method you use, so quadratic formula is fine. Just please don't try to use quadratic formula on every single quadratic because you'll probably run out of time on the test. Okay, so next one, completing the square, I got to isolate the constant, so I'm going to add 16 to both sides. Alright, so x squared plus 10x, here's my blank, and then that's going to be equal to 16 minus 4, that's going to be 12, plus another blank. Alright, half of b squared, so I take half of 10, which is 5, and I'll square that, which is 25. So I'll take a 25 and stick it in that blank. I'll stick that same 25 in the blank on the other side of the equation, keep it balanced. This perfect square trinomial will now factor inside a parentheses square piece. What goes in there? It's half of b. Okay, half of b. So half of 10 is 5. So it's going to be x plus 5 in the parentheses squared piece. And then over here, I just combine my like terms, the 12 plus the 25. That gives me 37. Take the square root of both sides. Square root of x plus 5 squared is just x plus 5. Square root of 37 is not a perfect square, so now if this were the square root of 36, then yes, I would just write, you know, plus or minus 6. Okay, but the problems you're going to see on the test are going to be decimals or radicals, because if I were to get a nice pretty whole number, that means that I could have used some other method like GCF or factoring. But you have to use quadratic formula or completing the square when you get decimals and radical answers. So the last step is to subtract 5 from both sides. So my final answer is x is equal to -5 plus or minus the square root of 37. Okay, sorry, you can't see that. -5 plus or minus the square root of 37. Okay, these next 4, they're asking you to use the quadratic formula. Quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. There you go. Throwing some music in there. And no, I'm not going to play the piano for you during the test. Okay, so you got to come out here to the side and you got to list out your A, your B, and your C. So what is my A? This is my A, that's my B, and that's my C. So my A is 3, my B is -3, my C is -5, and I'm simply going to plug these 3 numbers into the formula everywhere I see the letters. But here's the tricky part. It's -b. That's by default. That's in the equation. But my b is already negative, so it's -3. Okay, got to make sure you guys remember that. When the b is negative, that's going to be a double negative. That's going to make that a positive. plus or minus the square root of b squared. Okay, remember, if you're doing this on the calculator, you've got to put that in parentheses because negative 3 squared is 9. It is not negative 9. Minus 4 times a, which is 3, times c, which is negative 5. All of that over 2 times a, which is 3. Okay, all of that's under the radical. Now from this point, the way I taught you guys, you can either break this down and do it step by step mentally in your head, or you can just type all this in your calculator. But first we need to take care of this. Negative, negative, that's going to make that a positive 3, plus or minus. Now if you want to break this down, negative 3 squared is 9, negative 4 times 3 is negative 12, times negative 5 is a 60. You can do all that stuff. I'm going to show you how to do it real quick on your calculator. I'm simply going to type everything on the radical into my calculator the way I see it. Parentheses, negative 3 squared minus 4 times 3 times negative 5, and I get a number. Oops, sorry. All right, 69. Okay, so that's the number that goes on the radical. So for some of you guys, to avoid mistakes with all these negatives and careless mistakes in here, you can just type all that in and get a number. Okay, so it's going to be 3 plus or minus the square root of 69 all over 2 times 3, which is 6. And that's your final answer. Okay. All right, so number 18 here. Let's come out to the side. List our A is 3, our B is 2, our C is negative 4. Okay, so plug into my equation, negative B, which is negative 2, plus or minus the square root of B squared, 2 squared minus 4 times A, which is 3, times C, which is negative 4, all over 2 times A, 2 times 3, negative 2 plus or minus. Now this one I'll do manually. 2 squared is 4. Negative times a negative is a positive. 4 times 3 is 12, times 4 is 48, all over 2 times 3, which is 6. That's going to give me negative 2 plus or minus the square root of 52, all over 6. Okay, those numbers are pretty easy, so I just decided to kind of do that one in my head, but you can use the calculator as well. Okay, number 19. Whoa, what in the world? Huh. A is 3. What in the world is my B? I don't have a B term. Well, guess what? It's a big fat 0. There is no B term. C is negative 4. Alright, so it's negative B, but it's negative 0. Plus or minus the square root of B squared. That's 0 squared. That's a pretty easy problem. Minus 4 times A, 4 times 3, times C, negative 4, all over 2 times A. Okay, that's just 0. That's just nothing. Plus or minus, that's just nothing. So I got negative times a negative. That's a positive. 4 times 3 is 12 times 4 is another 48, all over 2 times 3, which is 6. Okay. Notice, guys, it would have been easier to use the square root method on this. You could have just, because there's no B term, you could have just added 4 to the other side, divided both sides by 3, and take the square root of both sides, and you would get the same answer. But they asked us to use quadratic formula, so we obliged. Okay, last quadratic formula. Lots of 3's here. A is 3, B is negative 3, C is negative 3. Okay, no problem. Negative B, negative 3, because the B is negative. Plus or minus the square root of B squared, put that in parentheses, minus 4 times A times C. All of this over 2 times A, 2 times 3. Lots of 3's. That's going to make that a positive 3, double negative. And then plus or minus the square root. Let's type this one into the calculator. I got a bunch of negatives here. I want to make sure I don't make a mistake. Negative 3 squared minus 4 times 3 times negative 3. That comes out to be 45. Okay, cool. 45 in the radical, all over 6. Okay, and that's your answer. Of course, once again, you can convert these to decimals and plug it back in if you want to check and make sure you don't make any mistakes. Okay, so that's it, guys, for the solving part. Now, part 2 of the huge quadratic unit was on the graphical stuff. All right, so the first one here, number 21, they want us to answer all of these attributes and characteristics. The vertex, that's an easy one. That's just the highest spot right here. That is just simply negative 3, comma 4. Page over here. Okay, negative 3, comma 4. Axis of symmetry, guys, is always this imaginary vertical line that passes through the vertex. If the vertex is at negative 3, 4, then it's always going to pass through the x, sorry, you can't see that. It's going to pass through the x coordinate of the vertex. And remember, the axis of symmetry is always a line. It's always x equals. It's a vertical line that passes through the x-axis. So it's x equals the x coordinate, so it's negative 3, passes through right there at negative 3. Domain, guys, is always negative infinity to infinity. Don't even think about it. Just boom, always. You always have x values on any quadratic. Max or min, this is a max. My roller coaster goes up and it reaches a high point, max, high point, and comes back down. So that's a max. X-intercepts. Now in this case, they pass through nice, pretty whole numbers. Right there at negative 1 and right there at negative 5. It's just where it crosses the x-axis. So we can just write those x-intercepts as negative 5, 0, and negative 1, 0. If they ask for the roots, technically I could just say negative 5 and negative 1. That would be fine as well. Y-intercept. Okay, y-intercept. This one is not quite so obvious. So how do we do the y-intercept? Again, with using our calculator, I can simply plug in my equation. So negative parentheses x plus 3 parentheses squared plus 4. And I want to go to the table. Now I'm simply looking, guys, is there any spot in the table where x is 0? Because that's what your y-intercept is going to be. I see it right there. Bam. And when x is 0, when I'm on the y-axis, I'm sitting at negative 5. Okay, so my y-intercept is going to be 0, negative 5. Okay, some of you guys might be able to look at that and just kind of eyeball it and say that, but you can use your table if it goes off of the graph goes off the screen and you can't see the y-intercept. Hint, hint. Then you need to plug it into your calculator and find where x is 0 in the x column. Okay, next one here. Max or min. My roller coaster is coming down to a low point, so that's a minimum. Range. This is the one that's kind of tricky for students. Paint the fence. Paint the fence. Karate Kid. We're sweeping up. Okay. Do I have any y values down here? I have nothing. This is a big void. I have no y's down here. I don't have any y's until I get to this spot. Okay. At that spot, I start having y values right there, and that's a y of negative 3. So my y values start at negative 3. Technically, that's supposed to have a bracket. And I continue to have y values all the way up until I hit what? Positive infinity. Okay. All right, roots. Now, in this case, we don't have nice, pretty whole numbers. It's crossing in weird spots. Okay, so we're going to have to use Mr. Spidey like we use in the real world problems. When the firework comes back down and hits the ground, it's not going to be nice, pretty whole numbers. The rocket's going to hit the ground after 9.28 seconds, that kind of thing. Okay, so we're going to use Mr. Spidey. Let's plug in our equation. Okay, parentheses x minus 3 squared minus 3. Let's graph it just to see what it looks like. And guys, if your window's all wacky, remember you can go zoom 6, zoom standard to get back to your standard window. And I want these spots on my calculator. I want that spot and I want that spot. Okay, so to get those numbers, I'm going to use Mr. Spidey, second calc. I want the x-intercepts, or the roots, zeros. They all mean the same thing. So select 0. And I'm simply going to move Mr. Spidey just to the left, or basically above, just to the left of that spot. That's good right there. I press enter. And then I'm going to move him just a little bit below. Don't cross, Ghostbusters, don't cross the streams. Don't cross the vertex. I just need to be a little bit below the x-intercept to the right. That's good. Press enter. Yes, I want you to guess. Press enter a third time. And there's my root, my x-intercept. We'll just round it to 1.3 is fine. 1.3, 0. Right, so that's one of my x-intercepts, and then I'm going to do it for the other one. Second calc, 0. Move Mr. Spidey just underneath it. That's to the left, just barely to the left. Press enter. Move him to the right, just above. Press enter. Press enter again. My other x-intercept is 4.7, 0. Okay. Remember, guys, feel free to rewind these videos if you don't follow me the first time. You can watch these things as much as you want. All right, axis of symmetry is going to pass through the vertex. In this case, I know what the vertex is because I'm in vertex form. I just flip that sign and leave that one alone. So the vertex is 3, negative 3. Okay, so the axis of symmetry is passing through the x-coordinate of the vertex. X equals 3. And we just found the vertex. 3, negative 3. Okay, for the end behaviors, very, very simple. All you have to remember is where are these arrows pointing? How is the graph behaving at the very end? These guys are both going up. They're both headed towards positive infinity in the y direction. So both of my behaviors are going to be positive and positive infinity. Okay, number 23, min or max. My roller coaster is going up, hitting a high point. That's a max. The range. Okay, do I have any y values down here at negative infinity? Down here, way down here. Paint the fence. Sweep from bottom to top. Yeah, I got y values down here everywhere. So I have y values from negative infinity all the way up until I hit that spot. All right, which is 2. After that, I don't have any more y values. This is a voided area. Okay, so my range is going to be from negative infinity up to a positive 2 with the bracket on 2. All right, roots. Okay, so again, for sake of time, guys, I'm gonna skip this. I've already shown you how to do it up here. I just showed you how to do that with Mr. Spidey. So for sake of time, for the purpose of this video, I'm just going to skip this and I'll let you guys do it. But you should get 0.59, 0, and 3.41, 0. Okay, so try that with Mr. Spidey just to confirm that that's what those 2 points are. Y-intercept, on this one I can clearly see it. It's at 0, -2. Extrema. Extrema is just another word for vertex, which is this spot. That's going to be 2, 2. So if you want to write vertex is another word for extrema, 2, 2. All right, where are both of my arrows pointing? Both of my arrows are pointing down, so both of my end behaviors are pointing, both of the y's are pointing towards negative infinity. Okay, last one here. What is the vertex? Okay, that's that spot right there. Vertex is going to be 1, 2. Okay, my axis of symmetry is this vertical line that passes through the x-coordinate of the vertex. So it's going to be x equals 1. Domain is what? It's always negative infinity to infinity every single time. This is a min. My roller coaster comes down and hits a low point. That's a minimum. X-intercepts. Where does the graph cross the x-axis? Nowhere. So I don't have any x-intercepts. I don't have any roots. I don't have any zeros. So that's just none. Y-intercept, once again, it might be a little bit tricky to see where that point is, so let's just check it on our table real quick. Let's type this in, x squared minus 2x plus 3. Let's go second table. Ah, there it is. I've got a 0 in the x column, 0, 3. So that is our y-intercept. Okay, home stretch, guys. You can do it. Home stretch. All right, 25 and 26. How do we complete the square to go from standard form into vertex form? I want to go from this form, the A's, the B's, and the C's, and I want to go into this form. This is vertex form here. Vertex form. Now we're going to complete the square to do this, but this is completely different than what I did on this page over here. Okay, this is how to solve, where you got a plus blank on the left and a plus blank on the right. None of that stuff apply. Well, I won't say none, but a lot of this stuff doesn't apply when you go into vertex form. It's a completely different process and strategy. I like to put, as you guys know, I like to put these little brackets right here, so my brain says, okay, I'm only completing the square on just those 2 terms. F of x is the same thing as y. It just means that I got a function. So I'll use y equals x squared minus 8x, and then now I'm ready for my blank. This is where I'm going to complete the square. So there's my first blank. And then I have the constant, the 18. And then I'm going to have another blank. But I don't know if it's going to be plus or minus blank yet. Okay, it depends. All right, so now I'm ready to complete the square. Half of b squared, half of b squared. Half of negative 8 is negative 4. Okay. Make sure the camera adjusts there. So negative 4, I'm going to square that. Negative 4 squared is 16. And that's the number that I'm going to stick in the first blank. But notice, once again, I can't say this enough, notice that both blanks are both on the right-hand side of the equal sign. So if I put 16 bricks on the right-hand side of a seesaw, then I got to take off those 16 bricks to get the seesaw balanced. So I have to offset those 16 bricks with taking those 16 bricks off. 16 minus 16, they just cancel each other out. I'm right back where I started. Okay, so why in the world did you do that, Mr. Moniz? Well, why I did that is so now I can factor this perfect square trinomial. I want to be in this form, so I know I'm going to have a parentheses squared piece, okay, just like the other method. So it's going to be y equals, go ahead and write down your parentheses squared. So to figure out what goes in this little piece is simple. It's just half of that number. It's half of b. Half of b is how it factors. So half of -8 is -4. So I'll put an x minus 4 in there. And then over here I just combine my like terms. 18 minus 16 is plus 2. And I am now in vertex form. What is the vertex? Flippy flip and leave that alone. So the vertex, the question doesn't ask for the vertex, but the test will. So the vertex is 4, 2. Okay, over here, this is the tough one. So when a is not 1, okay, we got to factor out that number. Okay, so I've got to pull out, I like to put my brackets here again. I need to pull out that -2. Okay, so if I divide -2x squared, if I divide that by -2, that will leave me with x squared. If I divide 12x by -2, that will leave me with -6x. I'm then ready for my first blank. I'll go ahead and close the parentheses. Then I have the constant, -19, and then I have another blank. Alright, so how do I complete the square? Half of b squared, half of b squared. I take half of -6, which is -3, and I square that number. This is always going to be, the first blank is always a plus blank because we're squaring something. So it means I always get a positive number. So I stick a 9 in that blank, but here's where it gets tricky. I can't just offset it with a -9. I've got to go back and redistribute this -2 times that 9. That gives me a -18. So -18 is the number we pulled out of thin air. Okay, so to offset a -18, I've got to put a positive 18 in that blank. And the rest of the problem is just the same as when a is 1. This perfect square trinomial factors is half of that number. So it's half of -6 is -3, so it's an x minus 3 squared. Don't forget to bring down this -2. Don't you forget about me. And then I just combine my like terms. -19 plus 18 is -1. Alright, so if I asked you for the vertex on that one, what would you tell me? You'll tell me to flip the sign, leave that one alone. So the vertex would be 3, -1. Okay, graphing. Sketch the graph. Okay, so I need 5 points in my t-chart. When I'm in vertex form like this, I'll do this one first because this is the easy one. When I'm in vertex form, I already know what the vertex is. I just flip that sign and leave that alone. So vertex is -4, 2. So I can already go to my t-chart and go about halfway down and put my vertex there. And then I just go to my calculator, plug in the equation, and get my data points. So I just plug in the equation, -2, parentheses, x plus 4, parentheses squared, plus 2. And let's go second table. And I just need to scroll until I get to the vertex. Where's -4, 2? Okay, there it is. And I'm going to grab 2 points above it. So I'll grab the -5, 0. Make sure I can see all this. I'll grab the -5, 0, and then the 6, -6, -6. And then I'm going to grab the 2 points below it, the -3, 0, and the -2, -6. And that's it. You just need to plot your 5 points. -6, -6 is down here. -5, 0 is up here. -3, 0, or excuse me, -4, 2 is up here. -3, 0, -2, -6. As a check, guys, what can you do? Well, let me go ahead and connect the dots. How do I know if this is right? Let's graph it and see. Graph. Better look like what I got. Yeah, looks like what I got. So that's good. All right, now 27. I'm not in vertex form. I had no idea what the vertex is when I'm in standard form. So you either manually, if you want to do this manually, you got to use the little -b over 2a. Plug in your b and your a. That gives you the x coordinate of the vertex. Take that number, plug it back in for x to find the y coordinate. That's how you do it manually. Or we can just use Mr. Spidey again like we've been doing. So let's plug this in. X squared minus 8x plus 12. I can do this so much faster than the manual way. Let's graph it, see what it looks like. Okay, I need the vertex. I need that spot. I need Mr. Spidey. Second calc, always second calc for Mr. Spidey. I don't want the x-intercepts. I want that's a minimum. Okay, so I'm going to go second calc and select the minimum. All right, where is Mr. Spidey? He's sitting at 0, 12, so he's way up here off the screen. So I need to move him a little bit to the right. There he comes. All right, so moving to the left. That's good. Enter. Move to the right. That's good. Press enter. Press enter a third time. There's my vertex. And of course, you can just round that. That's 4, -4. I can do that so much faster than doing the manual way. So my vertex is 4, -4. And I just need to go to my table, second table, and scroll till I see -4, 4, -4. Okay, there it is. So I'm going to grab those 2 points above it, 3, -3, and 2, 0, and the 2 points below it, 5, -3, and 6, 0. Okay, I like to put a box around the vertex just so I can keep myself straight there. All right, so let's plot those 5 points. 4, -4 is the vertex. 3, -3, 2, 0, 5, -3, and 6, 0. Okay, so let's connect the dots. Okay, and there's my graph. Let's just check it. Let's graph it. Press graph. Yep, it looks like what I got. That looks good. Okay, you can do it. I believe in you. You can do it. All right, we got 2 more problems here. 2 more problems. All right, Greenbrier's punter kicks a football. They want to know the hang time. I'm going to speed up a little bit here, guys. I only got about 5 more minutes before the bell rings. All right, they want the hang time. They want how long, all these real-world problems, they want to know how long does the ball stay in the air, what's the maximum height. So they're either going to ask you, and I got a video on this on my website, they're either going to ask you for the vertex or they're going to ask you for how long does it take to hit the ground. Time is going to be on the x-axis, height is going to be on the y-axis. They want the hang time. The football is kicked. It starts at a height of 3, actually. It's kicked, it goes up, and then it hits the ground. The hang time is how long does it take until I get to that spot. So I need the x-intercept. All right, so we're going to use Mr. Spidey. So I'll plug in the equation. -16x squared plus 48x plus 3. And I'm going to graph that. Again, if you got a wacky table, just press zoom 6. Zoom 6. Zoom standard gets you back to your standard window. All right, so here we go. The football is kicked. It goes up, reaches a maximum height, and it comes back down and hits the ground. I want to know how long it takes to hit the ground. I want that spot right there. I don't care about that x-intercept. I want the x-intercept on the right. So I'm going to go second calc. I need Mr. Spidey, so I'm going to select 0. 0 is the same thing as roots, x-intercepts. Okay, there's Mr. Spidey. I need him over here. I need Mr. Spidey to the left and to the right, which is basically above and below. So I can just look with my eyes. 1, 2, 3. It should be somewhere around 3. So I'll start clicking, and I'm watching this x value as Mr. Spidey moves up the spider web. I'll start to slow down. He should be getting close to 3 here. There he is. Okay, I'm above. 1 click above. That's fine. Press enter. I go 1 click below. That's fine. Press enter, and I press enter a third time. Okay, if Mr. Spidey's off the screen, guys, if you see him here and you go 1 click and you can't see him, that's okay. He's just down here. He's off the screen. That's okay. Hint, hint. All right, so there is my x-intercept, 3.06. So the answer to this question is 3.06 seconds is how long it takes for the football to hit the ground. Okay. All right, last one. Got to go quick. An arrow is shot upward. I want the maximum height, and I want how long it takes to get to that maximum height. Okay, so here in this example, what do we have? We got an arrow. The arrow's going up. It's coming back down. I want the max height. I want the vertex. Okay, this one was x-intercept. All right, I want the max height. So I'm going to plug in my equation. -16x squared plus 50x plus 20. Okay, and let's graph it, see what it looks like. Okay, I want the vertex. The arrow goes up, hits the height, comes back down. I need this spot up here. I need the vertex. Well, I can't see it on the screen. So we can use the little zoom trick. Zoom 0 or zoom fit. If you scroll down to 0, zoom fit. So just scroll down and press enter, or just press zoom 0. And miraculously, your calculator will zoom right in on that nice pretty vertex. So I need Mr. Spidey. So I'll go second calc. I don't want the 0. I don't want the x-intercept. I want the vertex, which in this case is a maximum. Select max. I need to move Mr. Spidey to the left of the left of the vertex. That's good. I need to move Mr. Spidey to the right of the vertex, anywhere up there. That's good. Press enter a third time, and lo and behold, there is my vertex. 1.56, comma, 59.1. Okay, so its vertex is 1.56, comma, 59.0 or 59.1. Okay, but now what's the answer to the question though? It says what's the maximum height? Is that the x coordinate or the y coordinate? Because here we go. Arrow goes up, hits the maximum height. The vertex is 1.56, comma 59.1. So the height is the y coordinate. Okay, this is the height. This is how high it goes. 59.1 feet. Okay.
I need the following students to the front office, please. Haley Jacobson,
the x coordinate,
Isaiah Brunson,
the 1.56,
Kyra Newton,
is how long it takes to reach the maximum height.
Russ,
So max height,
to the front office, please.
max height is 59.1 feet, and it's going to take 1.5 seconds to reach max height. Okay, so if they ask you how long does it take to reach the max height, that's the x-coordinate of the vertex. Hint, hint. Okay, boys and girls, that's it. I know this is a long video. Hope you guys enjoyed the video, pushed through, and are able to learn some stuff. And I wish you guys nothing but the best of luck on the test. And we'll see you on the next video.